Today we come to another important and very interesting topic, which is an elementary row transformation, and what we try to find out is an A inverse over here if it exists. Now if an inverse exists, then A into A inverse is equal to A inverse into A is equal to I. Since we are dealing here in the first question with a 2 by 2 matrix, therefore I have written I also as a 2 by 2. It's an identity matrix. The value of an identity matrix is 1. So we start with the first question, which has 2 rows and 2 columns, and I start with A is equal to IA. So therefore A is my original matrix, which is a 1, 2, minus 1, 3. I is 1, 0, 0, 1 and A. Now what is my aim? My aim is to convert this part into 1001. So this will become an I, and eventually in the process this will become an A inverse. So it will be satisfying this condition. For that we are first looking into this. This should be equal to 1. In our case, fortunately, this is equal to 1. So next, I move over here. Since I am using elementary row transformation, I should now convert this one as 0. In the process, if this gets converted into 0, now this should not change. If it is changing, then we've made an error. So now to convert this into a 0, next step would be R2 tends to R2 minus 2R1. And therefore no change in R1. I'm writing R1 as it is, and here too R1 as it is, 1, 0 and A, and this is going to give me a 0, and this is going to give me a 5 and a minus 2 and 1. So what was my aim? My aim was to get a 1, 0, which I have gotten over here, but I have moved in a particular manner. I am moving row wise. Now once this gets converted into 1, 0, next what do? I move to the right hand side. So now this element has got to be converted into 1, because the entire left hand side I am going to convert like this. So whatever is remaining over here, I shall divide it by the same, and R2 tends to R2 by 5. So no change in R1. We shall write R1 as it is, 1 minus 1. No change over here. It is always better that you write the first row first and then you write down the second row. So this is a 0. See, while performing the operations, the previous values are not changing. And this is a minus 2 by 5. And let me give some space over here. This was a 0 and this was a minus 2 by 5, and this becomes a 1 by 5 and A. So now what happens? Now this has gotten converted into 1, 0, 1. I'm left only with the last element. So now I move in the upwardly direction to convert this element into 0, and that means this element belongs to row number 1. So what do I have? R1 tends to R1 plus R2 should give me my final step, which is change in R1. No change in R2. I'm writing R2 as it is equal to minus 2 by 5, 1 by 5 and A, and this will be 1, 0, and this is a 3 by 5, and this is a 1 by 5. Now notice here that the entire left hand side has gotten converted into the identity matrix. So if I was to write over here properly, then what would this be? This is an I and this was an A. So this definitely has got to be A inverse. And look over here, I've already said A inverse into A. If this is equal to I, then this part is A inverse, which is our requirement. Now just to give you a shorter method, you can always identify whether your method is correct or not by a very small kind of a trick, which is, if you look at the question over here, I could have found out my answer directly. should know that A inverse is equal to adjoint of A by determinant of A. So A inverse is equal to adjoint of A by determinant of A. I could have found out my answer in 10 seconds by interchanging these two and reversing the signs over here. So if I interchange the two, I would have got A inverse is equal to, and this is 3 and 1 and minus 2 and 1 divided by the value of the determinant. The value of the determinant is what? 3 ones are 3, minus of minus plus 2, 5. So divided by 5. And you can see here that this and this answer is same. So once again, interchange the places, reverse the signs and divide this by the value of the determinant. What you get is A inverse, because what we have found out is the adjoint. Hope this video is helpful and thank you for watching.